Okay, any thoughts?
Yeah. So I would take, in the first example, AB is my sliding window, and I would start searching from the beginning of S2,
Mm-hmm.
and I would check to see if the elements in AB are in that first part of that window, first part of S2, just by
Okay.
using contains or something like that. And
So you would say, is AB in like EI?
yeah, or yeah, AB in AI.
Is AB a substring of EI?
Mhm.
Well, not necessarily. It doesn't need to be a substring, right?
Right, it has to be equal. Has to be a
The best
permutation.
case would have been if both were like if both are of equal lengths and one is a permutation of another, have a map and just like see one by one if we can reduce the count of every element of the dictionary to 0.
Okay, so I like the idea of using a map, right? So you're saying, so what's our window? What are we storing in the window? So in the last problem, our window is a dictionary, right? And our window is actually a counter, right? Here, what is our window?
I thought it should be the shorter string, but maybe I'm wrong.
The shorter string. So you want AB to be the window. So you're comparing AB with EI.
Mm-hmm. And then with ID and then DB and like that.
Okay, but what if I have like BCD? So your answer should be BCA. So, right? So if you're just comparing AB with EI, then no, it's not true, right? Then you compare AB with ID, no, still not true. Then you compare with DB, no, still not true. Compare with BC, still not true. Compare with CA, CA is still not true. You compare with AO, still not true. And then, so then your algorithm will return false, right? Because there's no substring of length 2 that's equal to AB.
Right. But should it return true?
Yeah, it should return true if S2 contains a permutation of.
Okay.
So, but basically, it's just a sliding window, right? We expand as long as our window. Well, we expand basically all the time, right? But at the moment when we detect that that sliding window has all of the characters from S1 plus maybe some extra, we shrink that window, hopefully to match the characters in the window string S1 exactly, right? So that's the idea. The only question is, how do we do this comparison, right? How do we check quickly that window has all the characters from that string?
Yes.
And we can do it very simply by having, well, Arun suggested the map, right? So we could do map, or we could just store counts of each character in the array of size 26 because we have only lowercase Latin characters.
Yes.
So when we check if sliding window, meaning count frequency array of 26 items, has all the characters from string S1, which is also array of 26 items, it's well, we can kind of cheat and say this is a constant time check because it's only 26 items.
Yeah. I think that idea makes sense. So you're saying we will just basically use two. I think using a dictionary is easier in terms of coding, right? So basically you have an S1 count that's saying, oh, I need 1A and 1B, right? So this is my goal, right? So initially S2 counts, let's just call it window, right? Initially the window is empty. So then you see an E, you're like, okay, so E occurs once. Now is S1 count included in window? No, right? There's no A, there's no B. So of course our window doesn't include S1. So fine, so we will expand the window. And we see an I, okay, so I will be added to the window. Still S1 count, line 12 is not part of line 13, right? So we keep going, then we see a D, so D would have a count of 1, then we see a B, B would have a count of 1, then we see a C, C would have a count of 1. And every time when we add something, we check if S1 count is part of window, right? Then when we have A1, so now S1 count is part of window, right? Because the window has an A, the window also has a B, right? So now S1 count is part of the window and we're done, right? Now this problem is very easy because you just need to return true if S2 contains a permutation of S1. They never ask you to find the shortest, right? I think a more interesting question would be, okay, find me the shortest substring of S2 that contains a permutation of S1.
So that would be BCA, right?
Yeah, that would be BCA, right?
Right.
So, and now how do we do that using sliding window? So after finding, okay, after seeing that line 13 now contains line 12, we need to shrink it, right? Because this window does contain S1. This window does contain a permutation of S1, but it's not necessarily the shortest substring that contains a permutation of S1, right? So how do we shrink it? Well, we shrink it similar to how we shrink in the last problem. We just keep incrementing the left pointer, right? So we were like, okay, so we need to record it. We need to have a left that initially is 0, right? Then we're like, okay, so we want to we try to exclude this left, right? We increment the left, so we remove this. Now one is left is 1. So now we check, oh, is Windows still contains, is line 12 still containing line 13? Yes. Okay, so that we can increment again, right? Oh, sorry, I becomes, yeah, I is gone. Now is window still a superset of S1 count? Yes. Okay, then we increment left and then we remove D, right? So we keep doing this until window no longer contains S1 count. So we know that, oh, we have already found the shortest substring that we have seen so far, right? But maybe there's some even shorter string to the right of it, but that's when we start to expand our window again, right? So we will remove B. Oh, B shouldn't be removed actually. So yeah. So that's it, right? So so then we started to remove B and the left becomes 4, and then now we realize, oh, window no longer contains S1 count. Okay, so well, what do we do now? We need to expand again. So we increment our right pointer, right? So we include a O1, right? Then we O1, right? Then we see another O, okay, O2, and we see another O3, right? But do we shrink? We do not shrink, right? Because our window doesn't even contain S1 count, so there's no point of shrinking, right? So this problem does not require left pointer if they only ask you to return true or false. But if they want you to find the shortest substring that contains a permutation of S1, then you do need a left, right? And we do need this while loop to keep shrinking until the window no longer contains S1 count. Does that make sense?
But we will need to shrink it here, right?
Why are we shrinking? The window doesn't even contain S1 count. What's the point of shrinking?
Oh, if window does not contain, then yes, we do not need to shrink.
Yeah,
but
then our goal should be keep expanding until we do contain S1 count, then we can shrink.
But how do we return BCA from this?
Well, we have an answer, right? Every time when the window contains S1 count, we update the answer.
Okay.
Right. Then when we shrink, we also update the answer, and the answer should be the mean between the answer and the current window, right?
Awesome.
So yeah. Of course, if the window doesn't contain S1 count, then we will not be updating the answer, right? Yeah. So this is pretty similar.
Oh, just to be sure we're on the same page. For this problem, we also need to shrink the window, right?
Why do we need to shrink?
So on example 2, right? So we have a S1 AB and S2. It has AB. Well, it has B or A, right? So let's say our window somehow magically covers BOA, right? Window of size 3. So in this case, the counts for S1 will be A1, B1 on our window, B1, A1, and O1, right? So window technically contains S1.
Yeah.
But
so
our
yeah,
response
actually,
should be false.
so this one, I think the wording is a bit confusing because they say S2 contains a permutation of S1. So it's not clear. You know, from example 2, we know that, yeah, actually BOA, they think that BOA doesn't contain S1, but I think
the wording is confusing here.
Yeah, right. So yeah, if they ask for exact match, they're like, oh, you know, I need you to find a substring that's exactly equal to a permutation of S1, right? Then I think there's no point of well, still we can call it a sliding window, but then we're talking about a sliding window of fixed size, right? That's what Sushil initially. That should be the solution that Sushil initially mentioned, right? So it's like we'll compare AB with EI, right? If they're not, if they are not permutation of each other, then we'll compare AB with ID, right? Then we compare ID, right? So there's no expanding or shrinking the window size. The window size will always be 2, right? If this problem asks you to find an exact match, right? But if this problem asks you to just find me a substring that contains a permutation, right? Then I think, you know, the solution I described makes sense, and you don't need to shrink the window. Does that make sense?
Yeah.
Yeah. So this I think the wording is pretty confusing. Yeah, but if the question, I think, yeah, looking at example 2, they probably do want you to find an exact match, right? In which case it's even easier because you are just comparing AB with EI. If it's not a permutation, EI is not a permutation of AB, right? Then you're going to be comparing AB with ID. Are they permutations? No. Then you're comparing DB. Are they permutations? No. You are comparing AB with BO. No. Then compare AB with OA, right? So you keep doing this. I mean, that's easier, but still, like, how do you quickly compare 2 strings if 2 strings are permutations, right? So you can quickly do that by using this dictionary idea, right? So yeah, you will be counting how many A's and how many B's, how many C's in S1, then how many A's and how many B's in your current substring in S2, right? So S2, let's imagine that our S1 is like super long, right? Something like this, right? Then yeah, so S2 will also be very, very long, right? So now if you're using the brute force, if you're comparing this with like this, right, it can be very slow, right? So we need to, and then you're comparing this with this, it's also going to be slow, right? It's going to be O of NK, where N is the length of S2 and K is the length of S1, right? So that's the brute force, and the sliding window solution will be O of N, right? Where you're just comparing 2 dictionaries. In S1, you're like, oh, you know, I've seen like 10 A's and 5 B's. Okay, 5 B's. I just need to find that in S2, right? So initially, the string I'm looking at is like this one, right? I want to find a substring of equal length as S1, right? So initially, maybe I have like, like 2 E's, 1 I, then like, 3, like 3 A's and like 6 B's, right? Okay, so this sliding window it's not a permutation, right? Then we're like, okay, then we need to update our sliding window. We can update our sliding window, update our dictionary in O of 1 time, right? By removing this E, so we remove this E, then we on the right pointer, we increment the right pointer, right? Maybe previously it was pointing to S, now it points to F, right? So we just add a F here, right? And then we check, oh, is to line 23, is this dictionary equal to the dictionary on line 22? If there is a match, then we return true. If it's not a match, then we again update our dictionary in O of 1 time, right? So that's how we can achieve O of N. Does that make sense?
Yeah.
All right.